Hello student, let us start question number 11 of exercise 6.1. Okay, so first I read the question. A particle moves along the curve 6y equal to x cube plus 2. Find the point on the curve at which the y coordinate is changing 8 times as fast as x coordinate. So what is given in the question? You see, a particle is moving along a curve. Along a curve, suppose this is a curve, along this curve the particle is moving. The curve is given by 6y is equal to x cube plus 2. This is the equation of the curve. It is given at certain instant. The rate of, you have to find out the point, that is, suppose I am considering the point as P. It is given in the question that P is a point on the curve at which the y coordinate is changing 8 times as fast as the x coordinate. Okay, the rate of change of y is 8 times the rate of change of x coordinate. So as our aim is to get the point, so I have considered the point as xy in the solution. Let the required point be xy. We have considered like that. You may consider other point also, x1, y1 or like that also. But I just consider this value as xy, so that we can do the calculation easily. Now what is given about the rate of change of quantity or the rate of change? It is given that the rate of change of y coordinate I have written in short, is 8 times the rate of change of x coordinate. So rate of change of y we can denote it by what? dy with respect to time, dy dt. dy dt is equal to x into 8 into dx dt. This is the relation between the rate of change of x and rate of change of y. Our aim is to get the value of the point. Your aim is to get the point. So you see, since this relation is given and the curve is given, so if I took the derivative of the curve with respect to time, then we can use this, and from there we are going to find out the value of x and y. So I just consider the curve. The given curve is what? 6y is equal to x cube plus 2. I'll take the derivative of y with respect to time, that is d dt of 6y is equal to d dt of x cube plus 2. With respect to time I have taken the derivative. The result will be 6 is constant, come out, dy dt, and here d dt of x cube is 3x square dx dt and d dt of constant is 0. So you see, you have got a relation between dy dx and dy dx dt and dx dt. So I just wrap the question for the remaining part, to write on the remaining part of the question solution. Here also, this part also I have just wrapped. Okay, the relation I keep it here. Now you see, I'll go to use now this relation here. In the place of dy dt, I can put 8 times of dx dt. So here if I substitute it, 6 into dy dt can be written as 8 times of dx dt, which is equal to, on the right side we have 3x square of dx dt. I have used here 1. From 1 we have got it. Just mention these things. Now you see, we can cancel out 3 from both sides. Sorry, dx dt from both sides. Right? So if I cancel it, this product will be 48 is equal to 3x square. On the equation containing x is left. So x square is equal to 48 divided by 3, which is equal to 16. So since x is a point, so x value will be equal to positive negative 4. Plus minus, both the symbol we are considering because it is a point. So it may be positive, it may be negative. After this you see, what I have to find out now, the value of y. Okay, now y can be find out from the given curve. Always see your curve. This is the curve. Let us consider this curve now. And on the curve where we will put here the value of x. When x equal to 4, you put it on the curve, then 6y is equal to 4 cube plus 2. That is equal to 4 cube for the 16, for the 64 plus 2 is 64, 66. So y value is equal to 11. And when we put x equal to minus 4, let us see what is the value we obtain. When x equal to minus 4, 6y will be equal to minus 4 whole cube plus 2, which is minus 64 plus 2. That is equal to what? Minus 62. And on calculation, y will be minus 62 by 6. Cancelling by 2 will have minus 31 by 3. Okay, so what we have got 2 points. Therefore, the required points are when I put x equal to 4, the corresponding value of y is 11. So one point we have got as 4, 11, and the other point is what? Minus 4, minus 31 by 3. So this is the solution of question number, what is the question number? Okay, so solution of question number 11. Now, let us go to question number 12. Okay. Now you see your question number 12 is, the radius of a bubble is increasing at the rate of half centimeter per second. 12. The radius of an air bubble radius of an air bubble is increasing at the rate of half centimeter per second. At what rate is the volume of the bubble increasing? What the radius of the bubble is increasing when the radius is 1 centimeter. When the radius is 1 centimeter. So what is given here, Justine? The radius of an air bubble is increasing. Air bubble, it is spherical in shape. Okay. So radius is increasing at the rate of half centimeter per second. That is the rate of change of radius is 1 by 2 centimeter per second. What is asked? The rate of change of volume of the bubble when it is increasing at the instant what? R is equal to 1 centimeter. So as earlier we are considering, let R be the radius and V be the volume. We have considered it. What is given? dr dt is given as half of centimeter per second. What is to find out? dv dt at the instant when r is equal to 1 centimeter. This is to obtain. So hope you understand what is the formula we have to use. Yes, we are going to use the formula of volume. Volume is 4 by 3 pi r cube. Rate of change of volume we have to get. So we are taking the derivative of v with respect to t. On the right side, 4 by 3 pi is constant. ddt of r cube will be there. So we have dv dt is equal to 4 by 3 pi. Taking the derivative, we will have 3r square dr dt. Now we can substitute, the 3 will be cancelled out. 4 pi r square, dr dt value is half. So substitution half. And after this, our aim is to we can do the calculation now. I just stop the question. After this, dv dt is what? Half you can cancel it to 2 pi r square, and then the variable volume changing with respect to time at the instant when r is 1 centimeter is what? We have to put r is equal to 1. So 1 cm square, and the unit is what? The volume, it is centimeter. So cm cube per second, and that is equal to what? 2 pi cm cube per second. So this is the solution of this question. So hope you understand this solution. Now we proceed to the next question, number 13. Okay. Let me write the question first. Your question number 13 is, a balloon which always remains spherical, which always remains spherical, has a variable diameter, That means here the diameter is variable. In the previous question generally what is given? The radius are given, but here this is, remember, the diameter is given. Variable diameter, and the diameter is given as 3 by 2 twice x plus 1. This is the diameter. Find the rate of change of its volume. Find the rate of change of its volume with respect to x. So you see, in the question the diameter is given. It is given that the diameter is 3 by 2 twice x plus 1. So if the diameter is given, you know the radius is half of the diameter. So we can find out the radius. And what is asked? The volume change. Rate of change of volume with respect to x you have to find. So let us consider again as earlier, let r be the radius and p be the volume of the balloon. Okay, so it is given diameter is equal to 3 by 2 twice x plus 1. So what is the radius? Radius is equal to half of the diameter, that is half of 3 by 2 twice x plus 1. It means that doing calculation 3 by 4 twice x plus 1. And in terms of volume, you have to change the volume. So volume formula we know, 4 by 3 pi r cube. But what is r cube? You have to put that value. That is 4 by 3 pi. R cube means what? 3 by 4 into twice x plus 1 whole cube. Now do the calculation properly. Carefully do the calculation here. 4 by 3 pi. This is 3 by 4. It will come 3 times. And twice x plus 1 whole cube. 1 3 by 4 can be cancelled out. So this is left. Let me write the question. And now you see the volume is what? This is pi is left, is a 9, 4 4 is a 16, pi twice x plus 1 whole cube is the volume. Your aim is to get the rate of change of volume with respect to x. So take the derivative of v with respect to x. On the right side also, this is constant, come out, ddx of twice x plus 1 whole cube. This is 9 by 16 pi. Taking the derivative, what we have? 3 2x plus 1 whole square. I have used x to the power n formula. And this is x, so this is x of twice x plus 1. Okay. Now, after this, what we'll have here? You just multiply it. Yes, on doing this derivative, 327 by 16 pi twice x plus 1 whole square, and this is 2. With the x of, that is 1 and 0, 2 will be cancelled out, that is what? 27 by 8 pi twice x plus 1 whole square. Now, hope you understand this solution, and today I'll stop here. Next video I'll do the remaining solutions. Thank you.